Right, so yeah, I was a bit off on my initial design. So what have I got here? It was one note, literally again after making that video last night. I just sort of was sat downstairs again, just having a cup of tea, and I thought, hang on a minute, I'm pretty sure I must have some transistors backwards or something here. And yeah, these are TO 126s. Is it 126? Yeah, TO 126. So they go base collector emitter, but they're reversed if you like look at it from the back side. So the way I've like drawn way I'd drawn like the input transistors feeding in, it was totally wrong. It was totally wrong. And the way I had this input stage configured was way off as well. So got up this morning, had a quick probe around, and yeah, when you're not tired after a day's work and it's getting late and you've had a sleep and let's say walked away, and you get circuit board blindness, you get lost in the tracks, and you're trying to hold so many things in your head, it all just sort of mixes together and makes nonsense. So some of the components are missing off here. The bias circuit isn't going to be, this whole bit here isn't going to be exactly what the values are. I've literally just made this up when I sat downstairs. I know it's in here somewhere. I was more concentrating on what I'd sketched out, trying to get it somewhere near to what it is. So again, the transistors aren't the right ones. They're just something that was close on the old CAD package. So yeah, it's a dual differential input stage. There's this. I thought these input stages were being referenced to like a virtual 0 volt point, but they're not. There's a Zener sort of Zener clamp voltage generator circuit on each half, which is feeding the bias for the long tail pairs at the input. So it's 15k resistor, so 7.5k. I measured it. It's somewhere around 5.5 volts, just with a 9-volt battery and a resistor. So it could be a 6V2, could be a 5V6. I've just gone with 5V6. Capacitor smoothing. So the upper long tail pair feeds off the lower one. The lower long tail pair feeds off the top. And what these are here are, they're basically, if you kind of even, they're almost like a common base amplifier. If you ever like know anything about radio frequency circuits, yeah, you have like common base amplifier. It shields AC across your lower high gain like transistors. It does away parasitic capacitances and stuff. However, that's not what it's being used for here. It's just basically being used as a voltage reference for the lower transistors to reduce their dissipation. So the bases are tied together. The upper set are going to the top voltage, this Zener voltage reference, and the lower set are going to the lower voltage reference. So that means that these transistors here, if this is at 0 volts, the emitters on these are going to be just below 0, and the collectors are going to be basically 5.6, 5 volts, whatever this circuit actually is in real life running. So there's only going to be 5 volts or so across these transistors. It enables you to use very low voltage parts, but it keeps dissipation down, way down. Now, as for the output stage, we'll start off with, I was adamant it was a triples configuration like this because I'd just probed. So you can see you've got different kinds of transistors here. It's probably easy to see on the other side. So yeah, I just probed like some PMPs and NPNs and stuff, and it was still on the heatsink at the time. Couldn't see where the tracks were going, and I had assumed it was this kind of affair. However, when I took the heatsink off and measured it, so I got the emitter follower part correct, but I thought this was like some weird like triples configuration. I was adamant, I had it in my head that this was a triples configuration output. So triples just means that there's 3 sets of transistors driving each other in the output stage. It isn't a triples configuration, it's just a standard excuse me, I'm getting a lot of throat blockage. So again, there are some components missing off this. I simplified it a bit just to make it easier to draw out, less cluttered. So the parallel output transistors will come off this point. This is the driver stage, so all of these transistors along here are basically this one and its brothers. This transistor here is this one, the driver, and this one, which is this transistor, is just a voltage amplifier stage. It's a dual voltage amplifier, so basically it's like a mirror image topology as one. So these are all receiving the same signal as this transistor is being turned on slightly more, eventually turning on this voltage amplifier stage. This one's being slightly turned off, turning this one off, and the two are in equilibrium with each other, which is why they could get away with killing the negative feedback and it still worked. I know it does it in real life because I've seen it doing it, and yeah, just quickly crunching this through the simulator, it does actually work. It will output a signal with no negative feedback. However, it will do like it was doing on the bench, and it's all over the place. I do need to check some of these values because according to what I worked out was going on, if you apply 1 volt signal with this being shunted with that 10 ohm resistor, it only gives about 5 volts output, which would be about a gain of 1,000, which, yeah, I know, how much gain does a transistor amp have without negative feedback? This is quite simple design, so a voltage gain of 1,000 is probably about all you'd expect. So I might have what the value shunting here was. It might have been 100 ohm or something, and I just misread it, misprobed it. As for this, yeah, I think I will try 1,000 ohms, so that should give a gain of about 56. It will certainly make the amp a lot quieter. Well, 57 should be theoretical gain, or somewhere around that point. So yeah, it's pretty simple. Like you see, there's no protection circuits on here or anything yet, but I've got this bit because I can now work out voltages. I can work out what kind of voltages I should measure at various different points. And like I've said, although that isn't a given, that if you find voltages that don't match what you've worked them out to be, it helps you narrow down where you're looking. So if I see a voltage here being excessively low, so let's say it's meant to be 5.6 volts and it's only 2 volts or something, it could be an issue with this Zener diode. It could be an issue with these transistors drawing too much current because something's shorted up here. It could be an issue with an open resistor here. It could be a shorted cap, but it gives you an idea of what place to look in. You know, if this voltage is low here, it's not going to be this transistor, you know. And again, if there's different voltages, say across these two resistors, but these ones are okay, straight away, well, they're not actually interconnected at the emitters, but they are in a feedback loop. But if the DC offset is 0, then it's not going to be the feedback loop ramping voltages up somewhere, affecting the input stage transistors to make them turn on and off by different amounts. It's going to be either an issue with something in this input stage. So you'd straight away, like, am I, you know, say this was drawing all the current and this one had none going through it. You'd be thinking, well, is there, you know, a short in this resistor? Is there a solder bridge or something causing it to have to pull a load of current to get this transistor to turn on? Is this transistor faulty? Is this one faulty? Is this one leaking too much? And this one's having to turn on extra to compensate to keep the voltage at 0 volts on the output. It gives you places to look in. It stops you from just randomly guessing, but more than anything else, having something like this to write some voltages down on, again, if you can't see what's causing it to start, you can walk away, and it's just weird how that works. You walk away, go do something completely different, and all of a sudden it'll just pop in your head, oh, what about that? That's exactly what happened last night. Yeah, I had a quick look in here just before I went to bed. I was like, you know, I think I'm right. Went to bed, fell asleep, got up this morning before I'd even finished putting my socks on. It was just on my mind. I came in here, had a quick probe. I was like, yeah, that's it. So went downstairs and knocked this up. So yeah, so I can do that today. Now I can go and measure some voltages and see if I can figure out where the problem lies. And it really could just be, you know, thinking about it, it really could just be because there's no bloody negative feedback, because when you started driving it higher, it wasn't as bad. When I biased it on, it wasn't being as bad. It wasn't that real prominent like distortion it was doing before. It was still there. It was a rounding of the signal. But as you crank the amp up, it seemed to go away again. So, you know, yeah, is it just minor differences in all the components? It at some point just is one set of transistors is turning off and the other's taking over. There's some imbalances somewhere, which is causing that weird flattening, you see. However, if it's doing that, is it because as it's trying to turn on, there's another one still soaking current or something? It's voltage probing time anyway. I can speculate all day long, but let me see if I can figure out where the problem lies. So I'm going to have to, I can't apply power to this without bolting it back on the heatsink, so I'm going to have to screw it all back on the heatsink, get it back in the amp, and do some voltage probing, see if I can figure out what is going on here. Well then, it's later on this day. I would have got this done sooner, but I don't know. I must have slept bad last night because I just kind of fell asleep on the sofa and dozed off on the sofa for a few hours. So the board is back on the heatsink. So the main issue before was huge amounts of distortion. Like it just sounded terrible, lots of buzzing and hissing from the speakers, and trying to put a 1 kilohertz sine wave through it, you know, within a few millivolts, huge distortion. So before, even on the 100 millivolt scale, within about 150 millivolts on the top half, it would distort. And yeah, on the 200 you could get it to be quite asymmetrical. And as I go up, it just nothing. All good. I can run it flat out. This thing has got some power. I give it full volume for a few seconds and my speakers up here felt like they was going to blow apart. So I've had to do some alterations. So I put the correct values in for the bias circuit. For some reason I had these down as 1K, they're 12K. But there's this odd little V adjustment circuit. If you look, let's see if I can zoom in on it. So this is still live in a minute. So see the potentiometer on the left, this one here, no sorry, this one here on the right with a resistor tacked across it. That is a DC offset circuit. So originally it was just odd. It had a resistor going up to each rail, but they were not the same value. One was like 300k, one was 150k. And then it had a 5k6 resistor tacked to the virtual 0 volt point, which is this one here. These diodes must be 14.7 volts or something, because I'm measuring about 15 volts now. They've actually got some current flowing through them. Yeah, that's why you can't use a 9 volt battery. So yeah, it went to a 0 volt point, but it connected to one side of the potentiometer, not the middle arm. It connected to the side which had the lower resistor to the rail. Couldn't really figure out why they'd done that. Couldn't really get the DC offset down where I wanted it. And so I put two equal value resistors in, adjusted the DC offset, adjusted the bias up, all seemed well, plugged it in, all of a sudden it started a real, like maybe once every 5-6 seconds, it would slowly start getting a large DC offset, which would be passed through this output transformer until it drew a large amount of current. The dim bulb would start to come up and it would just reset. And that is basically, it's a form of motorboating. It's because there's a time constant with the power supply capacitors and it's feeding into the circuitry in the amplifier. And because these are what was developing that reference voltage, although it's technically 0V, it's generated by two resistors between the rails. So as the rails start to fluctuate, the output fluctuates, the rails fluctuate more, and it's a slow positive feedback effect. So anyway, that was solved by simply just tacking a resistor from the virtual 0V point, a low value one from the virtual 0V point to the output of that potentiometer. Because these resistors are much lower value and they got capacitors across them, it stops that whereas just trying to use the high value resistors across it was no good. Yeah, I didn't really, to be honest, I probably shouldn't have messed with that bit of the circuit. I just didn't like the way it was configured. It was good enough, but anyway, yeah, I've got the offset voltage down to just a millivolt or so, which has 2 ohms impedance across this. So you know, it's a few milliamps flowing through it, but nothing deadly. I'd have liked 0, but it would have meant taking all the board off and messing around more. Things I didn't like was this. I'll just move the camera again. So this would come back down on top of live electronics. So yeah, this point here, it wasn't actually referenced to the main earth, like the 0V point of the 90 volt rails on the amp. Actually on the amp board, the whole input stage and feedback network, well, the input stage, its voltage reference was this virtual 0V point, and the feedback stage 0V reference was coming from here off this. Yeah, this is the weird setup. So there's 150k, this lower one was actually 300k. I've made them both 200k, removed that resistor and put a resistor across there. Yeah, so there was no actual genuine 0V point from the main rails, actual their tapping point on the power supply. So I've linked a 100 ohm resistor across from the 0V point on the board to that. I'm not really sure what they're doing. Maybe they was having an issue with a hum loop or something. But it referenced to the main 0V through the input connector. I thought, well, if that goes open, there's no 0V reference on the amp anymore. When you unplug the input connector, you've got a couple of volts DC offset. So yeah, 100 ohm resistor, all is fine. Other things worthy to note, if I put some music on, I don't know why I locked my phone there. If I put some music on, oh, bear with me. So if I put some music on, so camera won't really pick it up, but I now have bass. No negative feedback on this amplifier would have caused severe issues with output damping. It would have been worse than even the worst valve amps. But other things to note are, let me knock that up. Probably should have just done this with a sine wave, to be honest, but now when I disconnect one of the speakers, I don't suddenly get a spike in voltage, and when I disconnect all of them, if I disconnect that one and where's this one? Ah, come on. And you can see, even unloaded, I'm still getting the same output. It's typical. It looks like it's fluctuating a lot, but it's not. It just happens to be a bit on this song that moves around a lot. Come on, for Christ's sake. Right, so yeah, it's on a bit. You can see on the scope the level it's at if I connect the speaker up. Makes no difference. That's how it should be. So the question then becomes, why? So let me turn this off. So I can spin this board up by just unplugging. I've got to take it out anyway to put it back in its chassis. So if I point you down at the workings here, so the feedback resistor, I've put this resistor in. This is that one I was on about on that voltage adjuster. I could put it back to how it was and mess about with some resistor values, but no need, it's working. The feedback resistor I've put in is the one that's been taken out just, where are you? It was this one here, was it? Yeah, this one here had been removed and replaced with a blob of solder, and then this input resistor had been bypassed with a very low value resistor to attenuate the input signal, and I just can't see that being something, I just can't see that being something that it should have come out the factory like. So yeah, I've adjusted up the bias as well. That certainly helped things before I even did all this, but it just wouldn't make no sense. Is this I don't get it. You'd think, well, anyone who knows anything about amplifiers would know why you can't run a transistor amp without negative feedback, and certainly knows why you wouldn't do it with a bloody transformer coupled transistor amp. But then the question comes, how did it end up like this? The board was clearly designed to run as a standard amplifier with negative feedback. It's someone being in here. It's what was someone trying to achieve? Was there an issue with this that someone was trying to fix by eliminating negative feedback? Well, I don't know. I don't get it. What was going on? And I don't know. I don't get it. I don't understand what the issue was, because just I've not changed any other components apart from basically this bias network here and these feedback components. Everything else is working absolutely fine. The distortion's gone. It sounds great now. It's got tons of power back. Before, because the amp wasn't being driven properly as it was loaded up, the output impedance was all over the place. The VU meter would almost be flicking to full power, yet the thing was barely really doing anything. It sounded terrible because it had no damping, so there was no bass. It was just all high frequency, and you just think, what? I don't know. I don't understand what the issue was. I don't understand what someone was trying to do, and I certainly just don't believe it came out the factory like that. It just doesn't make sense. So yeah, so that is the amplifier side of things. Anyway, dual differential input stage. These are basically just voltage references to keep the voltage down on the input. Differential voltage amplifier stage. There's probably 100 picofarads here as well. I've missed off on my design. You generally have it on both. Bias network, and then emitter follower drivers and emitter follower output stage. Some people just call this a Darlington configuration. Yeah, working fine. All is good. I have no idea why it was the way it was, and how it ended up the way it was. It doesn't look like it's had any use. There's no dust in the thing. It's, as far as I'm aware, it was a brand new customer return, which then must mean it come out the factory like it, which is just boggling, because if this one's like it, then surely they must all be like it. And why the hell would they send them out the factory like that? I don't get it. Yeah, when I tried pulling this thing apart, all the glue on these connectors was still solid. Oh, where are you? Come back. All the glue on the Molex connectors was still on. So some I've managed to pull apart ever as the Molex connector actually came off the board. So it just left a pin sticking out. Which again suggests no one's been here, which is just... I don't get it. I don't know. I don't get it. I've got to put this bit back in. I think the next bit to net and test is going to make sure the 24 volt section and stuff is working. I need to test absolutely everything on this, because it's a very expensive amplifier to buy new, and the last thing I want to do is send this out ready for use to find out I've missed something blatantly obvious on it. And the other weird thing is so the output connector on these is a standard, what do they call it? It's one of these basically. You get them in like multiple, zoom back out. So you get them in multiple amounts of pins. So this one, look, your wire terminals go in this side and it pushes into the amplifier. However, this is the first one I've ever come across where it's like this end on the amplifier, and what it would need is the sort of pin version of this. So it's hard to say whether it's male or female. If you go by the inner hole, this would be the female connector, and the one on the amp would be the male connector generally. But if you're going by the outer point, and the outer point plugs into the inner point, so you'd say, well, the outer point's the male one. So it depends on which bit you're talking about. But yeah, this amp like has this bit on it rather than the standard one, which is the pins which stick out and plug into this bit. I'll be buggered if I could even find like a version of that. So basically, you know, with the screw terminals on it, that was the other way around to this. So I've gone and brought I think it's 5-pin. Yes, I've gone and brought a 5-pin one of these and the 5-pin printed circuit board mount one, and hopefully I'll be able to unsolder this and solder in the one that most people would be used to using. So I don't know. Because obviously it's second hand, it came without that. So yeah, all I know is another one fixed. It's another one up and running. I'm gonna give it some load testing and see how much abuse it can take. I want to firstly see how much power this thing will put out, and then secondly, I want to get it red hot, really, really red hot, and make sure everything's working and it doesn't have some weird thermal intermittent fault. But that's all for now. It's another successful fix. Yeah, this helps. Take some time, try and reverse engineer, and do yeah. If you get circuit board blindness, just keep walking away and come back later, and you'll eventually end up figuring out what's going on. So yeah. Anyway, it's working, and it's time for me to put the kettle on. So as always, thanks for watching, and catch you next time.